All right, welcome to today's class. We're going to talk about impulse and momentum. So, momentum is mass in motion. So, momentum is basically mass times velocity. Is a vector quantity basically because of the velocity there. Velocity is also what a vector quantity. It has direction and magnitude. Look at this problem. We have 10 kg and then it's moving at 6 meters per second, right? So the momentum will be mass times velocity, 10 times 6, which is 60 kg meter per second. All right, forward momentum of that body. For impulse is said to be the product of how long the impact of a force is felt. So impulse is J, which is force times what? Time. So impulse is equal to change in momentum. So you have force is equal to mass times acceleration, but acceleration is what? Velocity over time, right? So if I put it there, I have Ft equal to mv, which shows that impulse is equal to what? Momentum. Now look at this problem. I want to solve it. A boy shoots out water that lives at a speed of 20 meters per second and a flow rate of 5 kg per second. Find force exerted by water on the block. So mass flow rate is mass per time, right? So basically, we have 5 times 20, which is 100 Newton. Now, elastic collision. In an elastic collision, both momentum and kinetic energy is conserved. So we conserve both momentum and kinetic energy. U1 is initial velocity, while V1 is final. U is initial, V is final. Then for kinetic energy, we said it is being conserved. So kinetic energy before collision is equal to kinetic energy after collision. So that's basically one thing that we should put in mind. Then we have another type of collision called inelastic collision. And in inelastic collision, momentum is conserved, but kinetic energy is not conserved. That means it's not retained. Kinetic energy is not retained, it's not conserved in an inelastic collision. So if two balls hit themselves, so they tend to move with a singular velocity, right? The new common velocity. So that's basically what inelastic collision tells us. They stick together and move with a new velocity. Okay, so let's look at each problem. A 4 kg ball moving east at a speed of 5 meters per second strikes a 2 kg ball at rest. Calculate the velocities of the two balls, assuming a perfectly elastic collision. So momentum is conserved, kinetic energy is also conserved in this collision. So we want to find V1, that's the velocity after collision, right? So basically we make use of this formula. And then when we put in the values, we have M1 as 4 kg and then U1 as. So the second body, right? The velocity of the second body, basically we find it out by using M2 M1 all over M1 plus M2 U1 minus what you have there. So our answer is going to be 6.67 meter per second. That's basically what it will be. So look at the second problem. An 8 kg ball traveling at 6 meter per second strikes another ball moving west at 5 meter per second. Remember, if it's moving west, it simply tells you something that is negative, right? Western direction means it's going to be negative. So just take it that way. So we have this V1 is equal to, you're looking for the velocity, final velocity of the first ball, which is the 8 kg ball. So the final velocity now of the other ball, which is the what? The second ball that was at rest. So it was at rest because the initial velocity was 0 at that point. So basically, after we are done with this, we are going to get 7.57 meters. So the two balls move in opposite direction after collision. Okay, our answer, the two balls move in opposite direction basically because of the first answer we got was minus sign, and the second answer we are getting is a positive sign, has a positive sign. So a 10 kg block moving east at 15 meters per second collides with a 5 kg block at rest. Moving, the two blocks stick together. What is the final speed of the two blocks? So we have M1U1 plus M2U2 plus M2U2 equal to M1V1 plus M2 v2. So if they stick together after collision, then remember it now have a common velocity. So we have 10 times 15 plus 0 equal to 10 plus 5, right? 10 plus 5 v, right? So 150 all over 15. So we have 15v divided by 15. So 15 cancel 15. 15 going to 150 will give us v as 10 meter per second. So basically, the other one was 0 because of the block was at rest. The 5 kg block was at rest. So that's basically why we have 0 there. 0 times 5 will still give us 0. So there's no point doing anything. Okay, let's look at the next problem. We have a 15-gram bullet is fired horizontally at a speed of 350 meters per second into a 12 kg block that hangs by a vertical string. If the bullet remains embedded in the block, what is the final speed of the bullet and the block? How high will the bullet block system rise? Okay, m1u1 plus m2u2 equal to m1 plus m2 times v, basically because they are embedded together and they remain fixed together, right, after collision. So you change the 15 grams to kg. You divide by dividing by 1000, so that will give us 0.015 kg. So and then times 350 blocks. Zero basically because the other one is at rest, right? The hanged body is at rest. That was being this was fired, the bullet was fired into. So what you're going to do now is 0.015 and 350 is going to give us 5.25, then equal to 1.215 v. So v will now be equal to 5.25 divided by 1.215, which is 4.32 meter per second. All right. So you must take note that kinetic energy is conserved after collision, but not before the collision. So kinetic energy is equal to potential energy. We have half mv squared equal to mgh. So it's independent of the mass. So you can take half v squared. V is the velocity, the final velocity, which is 4.32. 4.32 squared times half is going to give us 9.3355. If you divide it by 9.8, you're going to get 0.92526 meter per second. Thank you for watching. Subscribe, like for more. All right.